we're just going to assume that it's complete combustion. All right, you're going to need oxygen in the reactants. And if it's a hydrocarbon, then the products are going to be carbon dioxide and water. C-H-O-O. 2, 2, 2, 1, 2, 2 from the carbon dioxide, 1 oxygen from the water. Multiply that by 2. Get 4, put a 2 there. That'll make that an even number. Okay, 2. All right, now let's go balance the hydrogen on the left side. Get that 2, make that 4, put a 2 there. All right, update that carbon also by 2, get 4. All right, so now we need a 4 on this side. 4, put a 4 there, coefficient in front of the C. Update that oxygen, which is this right here, times 4 is 8. Total of 10, and multiply that by 5 is 10. Now we can get on the stoichiometry. Please balance your equations. Your stoich will not work out. How many grams of water can be produced? Pick a different color. All right, how many grams of water can be produced? So we're looking for that information by the reaction of 2.4 moles of acetylene with 7.4 moles of oxygen. I'm going to do stoich twice, okay, to find the limiting reagent. And then there's a second part to that. We'll get back to that. All right, how much water can we make? All right, how many tables can we make? We have a certain number of tabletops and legs, or whatever analogy we used in class. Tacos and grilled cheese sandwiches and bicycles. And all right, I'll do the acetylene in blue. 2.40. We don't have to do step 1. 2.40. C2H2 gave us moles. We can go right into step 2, the mole ratio. What do we ask to find? Water. How much water? How many grams of water? So we got to first turn it into moles of water before we can turn it into grams of water. All right, and the mole ratio is, it's right up here, 2 to 2. Oh, nice. We didn't need this step. All right, but let's just do it, 2 and 2. All right, that's just going to be the same number. Oh, hold on, we're not done yet. Step 3 we got to do. Step 3. Now we're going to turn that moles of H2O into grams of H2O. All right, that's going to be, that's the molar mass for water. Okay, no regrets. I can sleep tonight. 43.2 is the answer. 43.2 grams of H2O. That's not our answer. Hold on. Let me do this in green. I'll do the oxygen in green. 7.40. 7.40. How many moles of oxygen? 5 moles of oxygen to 2 moles of water. Boom, boom. Turn that into... Now I'm double glad I actually did the sig figs because I would have needed it again here. I'm just copying from what I just did earlier, right up there. All right, that's going to be a common thing you'll see. 53.3. Grams of H2O. If we had these quantities of the reactants, we would only be able to make 43.2 grams. We would only be able to make this amount because we don't have enough acetylene to make more. So this is called a limiting reagent, and this here is called the excess, the reagent in excess, or excess reagent, the stuff we left over. This is going to be our answer. 43.2 is our answer because we can't make more without more acetylene. 43.2 grams is the answer. All right, what's the percent yield? One more to go. This is actually produced. Now this is, by the way, this is called a theoretical. Like if we could make the maximum amount given these quantities of reactants, this is called a theoretical yield. It's just the maximum we can make. Now, but we actually, it's rare that you make exactly the theoretical because there's a lot of factors a lot of things that can go wrong. So 39.9 grams of water is actually made. Actual over theoretical times 100. That's the formula we're going to use. 39.9 grams was actually made. That's what it says. Theoretically, we could have made 43.2 grams. So 92.4% yield. That's called the percent yield.